On C, notice I start to see pluses and minuses, which means I need to start worrying about whether or not I need to factor before I cancel. So in the first fraction, there's really nothing I can factor. I've got an a, b, c cubed, an a plus 1, times a c over a squared, b squared, times a squared plus a over AC. Where we run into our issues is this last numerator. That guy can actually be factored. Notice there is a common factor of a in both of those terms. So we can factor out an a. So we're going to replace the a squared plus a with a times a plus 1 because we're going to factor out that a. Notice we now have a common factor of a plus 1 that's on the top and on the bottom. So we can go ahead and cancel those matching a plus 1s out completely. Notice we also have at least one a that matches on the top and the bottom. On the last fraction, we have an a on top and an a on the bottom that can cancel out. We also can cancel out one more a from the top of the first fraction with one of the ones on the middle on the bottom fraction. Notice that does leave us with one a left over on the bottom. Now, as we keep on moving along, we can cancel out one b from the top of the first fraction with one of the b's on the bottom. But again, notice that leaves us with an extra b on the bottom. And let's look at C's lastly. Lastly, there is one C we can cancel out from the top and the bottom on the middle, the top middle of the first fraction, top middle of the middle fraction, and the bottom of the last fraction. But that leaves us with a C cubed that cannot be canceled on top of the first fraction. So we'll have a C cubed on top of our final answer. Let's move on to the last problem on this page, D. Notice there is one thing that can be factored. It's the numerator of the first fraction. You can factor out a 5, which would leave you with x minus 2. Now notice though, this is the first time this happens, but nothing cancels. There's no identical factors. So we have to multiply everything on the top over and everything on the bottom over. So what that does is on the bottom, when we had the x plus 1 and the x plus 5, when they were alone, we didn't need parentheses, but when we multiply them, we've got to pick up parentheses. So it becomes x plus 1 times x plus 5. And on tops, we have the same thing going on. We have an x minus 2 and an x that are multiplied. So I'm going to put the x out in front and the x minus 2 second. But we also are multiplying two regular numbers. We have a 5 times a 5, which is going to give us 25. But nothing actually reduced out of the fraction. We just multiplied everything out. So this is our final answer. And we can't do anything beyond this with it because nothing is identical between the numerator and the denominator.